In today's video, I'll show you how I solved the registry machine on HackMyVM. While working on this machine, I encountered vulnerabilities such as local file inclusion, log poisoning, and buffer overflow. For me, the buffer overflow part was the trickiest, as it was new territory. However, I will be trying out more machines with buffer overflow because I find them quite enjoyable. Now, let's get started. As usual, I began with a port and service scan using Nmap with the following options. P to scan all ports. Open to focus on open ports and exclude closed or filtered ones. Min rate 5000 to send a minimum of 5000 packets per second to the target. N to disable reverse DNS lookup. PN to assume the host is alive. SS for a scene scan, a stealthy technique that doesn't complete TCP connection to remain unnoticed while gathering information about open ports. V for verbose output. For service and version recognition, I used the following options. SC to activate the default script execution for vulnerability detection and additional information during the scan. SV to enable version detection of service on open ports. Nmap identified two open ports, 80 and 22. Since Nmap didn't reveal anything interesting, I checked the website and stumbled upon a landing page. I reviewed its source code as it often holds clues or intriguing information. I found a URL with a parameter page, and its format signaled the local file inclusion vulnerability. I tried common payloads for this type of vulnerability, but I didn't get any results. So I discovered a script that allowed me to scan more effectively and find the right payload. The script was quite old, so I modified it to make it functional. You can find it in my GitHub and adapt it to your needs. Next, leveraging Apache logs, I performed log poisoning to gain access to the system by exploiting both local file inclusion and log poisoning. After gaining system access, my first step was to search for sweet privilege binaries. That's when I stumbled upon the program binary. When executed, it asked for an argument, but it didn't return anything when I provided it. To trigger a buffer overflow, I supplied multiple A arguments which caused the overflow. Since I wasn't entirely clear on buffer overflow concept, I conducted research and reached out to the community. This effort allowed me to successfully exploit the buffer overflow using Pound tools. Define the offset for the buffer overflow. Construct the shell code. Generate the shell code to set the effective UID using setResuite syscall. Generate the shell code to spawn a shell using xvsyscall. Generate junk data to fill the gap between shellcode and return address. Specify the target address to redirect execution to. Construct the payload by combining the shellcode, junk, and target address. Create a process to run the vulnerable program with the payload as an argument. Start an interactive session with the spawned shell process. Once the buffer overflow was exploited, I gained access as another user, the owner of the binary. Upon executing the sudo l command, I noticed that this user could run a program using wine as the Gato user. This led me to another buffer overflow, this time targeting Windows. This particular buffer overflow was simpler, as I had practiced it on machines like BrainPan or Bone Server. My first step was to download the program to my machine for testing. With a small script, I determined the offset. Using the Mona tool, I then identified the bad characters and the jump point. Finally, using MSFVenom, I crafted a reverse shared payload. I successfully execute the local buffer overflow, and I replicate the process on the victim machine with the same outcome. After gaining access to the machine as the Gato user, I encountered another binary. Running it resulted in the same behavior as the first exploited binary, indicating the likelihood of another buffer overflow. Running the checksec tool on the binary revealed that it had an X enabled. In this case, I employed the red tulip C technique. This approach allowed me to successfully conquer the HackMyVM Registry machine, which had proven to be quite challenging. Working on this machine taught me a great deal. It's important to note that this video isn't intended as a tutorial. It's a project aimed at helping me practice and solidify my understanding of this concept. Remember to subscribe, like the video, and leave a comment. Until next time.